How are you all? Have a great morning. This morning fills with lot of happiness and energetic. So this session will be very fun. We are here not only to clear the topic which we are discussed a couple of minutes ago on previous classes. So we guys are here, our teammates, to clear some doubts in mathematics and DBMS. First of all, I have a quote. Alone we can do very less, and together we can do much, so much. How many of you agree, guys? How many of you agree with me? Please raise your hands. Because it's a true word, it's a true quote. In future, we are going to engage some projects, right? So in that we just need a teamwork. Because when we engage the topic, when we engage a project, there is a much more topics. We can't clear anything lonely. So we just need a teamwork. Like that, I'm here to introduce my teammates and myself. This is Vishnu Devata, you can call me Vishnu. And my teammate Pavni, he is going to explain M3. And Tejaswini, she is going to explain DBMS. Hope you guys have doubts and you can ask them without any fear. We are so much friendly to you. That's it, guys. Thank you.
Please stand and say. Can tell what is the meaning of the vector calculus? Okay, then vector calculus is also known as that vector analysis. It is used in mainly in differential equations and partial differentiation. First of all, we have why we can learn that the vector analysis. We are machine learning students, maybe right? Just for fun. So, in machine learning, we can also use the vector calculus and data mining, and this is the applications for the vector calculus. First of all, I have said that what are the topics under the vector calculus? Vector integration, vector differentiation, vector integral theorem. These are the basic topics in the vector calculus. The mark is not working, that's why I am not written from it. Sorry for the interruption. Vector calculus. What is the meaning of the vector? Please say that. Last benchers. It has only magnitude. And what are the examples for the vector? Please say that one word. Can you hear? Okay. Time and temperature. These are the examples for the vector. And another one is the opposite for the scalar. What is the meaning of the scalar? It has both magnitude and direction. Okay. In this, we have taken an example, force, etc. It has a direction. And then we have vector integration and vector differentiation. Vector differentiation. In this what we have differentiation. We learn that in this the subtopics curl and divergence, differentiation. These are the subtopics of the vector differentiation. What is this? An operator. Maybe right? Thales, del. Del equal to the formula of this gradient. It is placed in front of the gradient, then we call, suppose we have pi. It is a function. And then we have right a del operator can be a gradient. These three functions are replaced with in front of this operator. Then we call as a curl, divergent and then gradient. Gradient. Gradient means an operator pi. It can be written as a del pi. And then the function is said to be a gradient function. And then in divergence, we have in this divergence we have dot product. That means we have example scalar product. How can we take a two vectors? When we dot product, that means I dot I. That means I dot I dot product. Two vectors are make a dot product, then the answer is 1. So in divergence we have multiply dot product with the two functions, two vector functions. Then we have one. Suppose we have taken R is suppose a vector xi, yj and zk is a vector function and is also called as a position vector. We know that. Suppose we have another function that is equal to I vector divided x plus and j bar dou by dou y plus k bar dou by dou z. When we have dot product these functions, we have get only x dou by dou x. May I be right? Please say that, right?
Yes.
So this is the divergence. And make a little sum for the concept of divergence, direction derivative and gradient. I take an example for the function f is equal to xy plus yz plus zx. This is the function, it is along with the direction vector. Phi is equal to I plus 2j plus 2k at the point 1, 2, 0. In this we have, first of all we find a del of f. What is the del of f? Can anyone come to the stage and write what is the del of for the function? Can anyone please stand up and come to the dais? Okay, then fine. Del of. Here the function we have right I d dou by dou x plus j bar dou by dou y plus k bar dou by dou z. In this we have x functions xy and zx. Right? So we have differentiate for these two parts. This differentiation part of this y plus z. For this we have y part xy plus yz. For this differentiation x plus j bar. And then we have differentiate k z part. And then we have z and x plus. This is the del f function. We have created del f function. We have to find directional derivative. Directional derivative. The formula for the directional derivative is E dot del f. 5. You also know that E is equal to, what is the 5 value? And modulus of 5 value, we can calculate the front of the pieces of the paper like this format. Modulus of 5. How can we calculate modulus of 5? Can anyone? Root over. Nice. 1 square or 1? 1 square means? And then?
4 plus 4.
What is the answer? Root over means 3. We have calculated the 5 value, E value also. Then we can calculate the direct derivative of this function. Easy? So, direction derivative. E caps del F bar. Here E value is I plus
2j bar plus 2.
2j bar plus by and del F function
Plus j bar.
and del F function. Once done with the del F function.
Y plus z.
Y plus z plus x plus z with k bar plus x plus y.
How we are